Welcome back. Today we have again some very good problems from the Allen score test series of 2024-25. So basically this is the first question for today. So I will pause for a minute so that you guys can try it out. Now I will start off. So basically this is a limit that we have to solve, and this comes equal to m by n, so we have to find 2m minus n. So I will directly write out the limit. So this is basically our given limit. So what I will do is I will write this as limit x tends to infinity, x ln, and then I will take this power minus x to the denominator. So basically this is e into 1 plus 1 by x power 1 divided by 1 plus 1 by x power x. Basically because I want to segregate all these terms as ln is present. So now I can write this as limit x tends to infinity x, and into this, if we actually break this, or the both of these are in product form and this thing is in the denominator, so it is in the quotient form. So first this will become ln e, which is 1 plus of ln 1 plus 1 by x, and this is minus of x ln 1 plus 1 by x ln, because this power came down. So basically, yeah. And now as we have x tends to infinity, so as you guys will know, x tends to infinity for this particular expression is not looking good. And if you have solved standard sums of limits, we usually try to avoid infinity if we don't have something like taking the highest power in the denominator. So what I will do is I will substitute in this particular step, I will substitute x as 1 by t. So basically if x is tending to infinity, then t will tend to 0. So now we can write this as limit t tends to 0. This has become 1 by t, and this is 1 plus ln of 1 plus t minus x is again 1 by t, and this is again ln of 1 plus t. So now I will write this as limit t tends to 0. I will take this 1 by t inside, so this will become ln of 1 plus t power 1 by t. I just took this to the power because 1 by t after getting multiplied here, this can go to the power with properties of log, and this thing will become minus 1 by t squared ln of 1 plus t, and we have plus 1 by t from here. Okay, so I will change the page. So basically what I will try to do is I will try to write this in a better form. So let this stay whatever it is, ln 1 plus t power 1 by t, and now I will bring these two into one particular expression. So this will become plus t minus, because we have 1 here and t square is the LCM, so t minus of ln 1 plus t divided by t square. I'm sorry, this line, this is a straight line, by t square. So now what I will do is, because I am seeing everywhere that there is a ln 1 plus t, I will substitute ln 1 plus t as y. Basically this limit is actually all about substitutions, otherwise you can solve it in the normal way but it will get too complicated. So this is the better process. So 1 plus t is basically e power y, and now you can notice we have t's also in various places, so t from here this will become e power y minus 1. So I will try to manipulate this now. So if you guys manipulate this after putting this t and substituting this also obviously into this expression, this is what you will get. I'm not manipulating this because this thing is actually pretty simple. If you manipulate this, you will get this surely, and if you have any problems you could tell me in the comment section. I'm not manipulating this is simple step. So now as you can see, if I segregate this, I will do it here only. This is limit y tends to 0. This is e power y minus 1 by y squared, and this is minus 1 by y. Or instead, actually we don't need this step. Instead, what you could do is you could actually put y tends to 0 directly. Or what you could do is, if this is 1 minus 1, you can see a 0 by 0 form. You can also apply L'Hopital's rule. So whatever you do, there are many like processes to do this. If you can apply L'Hopital's rule also here, that is also okay. This will actually come out to as 1 plus 1 by 2, because after L'Hopital's rule, okay, I will do it for you. This is actually limit y tends to 0, e power y is e power y. This is minus 1. This is pretty simple, and this comes out to be as 2y. So basically, if you take this half outside, and e power minus 1 by y is a basic limit, and limit y tends to 0, so it comes out to be 1. So basically, we have half. So, and we had 1 here. So the final answer to this question is 3 by 2, which was given as m by n. So now I guess we, in this particular question, we had to find the value of 2m minus n, which is basically 6 minus 2. So your answer for this question is 4. This was a good question on limits. Now we will proceed to the next question. So our next question is from permutations and combinations. So basically there is a man who has to distribute 8 different chocolates among his 3 grandchildren. That is basically what you have to do is, the main point here, noticing this is just stuff written to say that we have 8, total of 8 chocolates, and we have to distribute them in 3 particular ways so that their sum comes out to be 8. So we will do that, but at first you have to notice something, that each of them receives at least 1 chocolate. This is important, which means that when you actually find out the number of possible ways, you can't make anyone 0, because they have to receive a minimum of 1 chocolate. If this was not written, there would be maybe more possible ways out. So now we'll proceed with the question. Basically this is very simple. If you do 8, I guess you can only divide it in 1 to 5. Or there is another way, which is, I guess, 1, 3 and 4 chocolates. This is chocolates. So these are the 2 probable ways, because we can't do 0, so there is no other option, I guess. So basically, if we find out the total number of ways, this will become an 8 factorial by 1 factorial, 2 factorial, 5 factorial. I guess you can understand this. This is using division of objects from permutations and combinations. And now if we check for this, this is 8 factorial by 1 factorial, 3 factorial, 4 factorial. Now basically, because we have 3 ways here, so in both of these there will be a 3 factorial multiplied. So what I will do is, we have to add these two, and I will take the 3 factorial common outside. So this is our expression for the question. Now we need to calculate this. So basically this is 8 into 7 into 6 into 5 factorial gets cancelled, divided by 2. This thing is 8 into 7 into 6 into 5 into 4 factorial, which again gets cancelled. 3 factorial is 6, and this is 6. So I will calculate it for you guys. So this is the final calculation. 280 plus 168 is, I guess this will come out to be as, I will just check once. This thing will come out to be as 448 into 6 will give you 2688 as the answer to this question. So now we will proceed with the next question. So here is our next question. So this was a pretty simple question. There is a lot containing 4 defective, and I will write this. This is 4 defective and 6 good items. So basically from here, out of these total 10 items, we choose 4 items at random, and after inspecting we find out that 2 of those 4 items were found to be good. So we have to find the probability that 4 of all those chosen items are good. So basically we need to find out the probability of P, G, G, G. G means here good. So this will basically be, so this thing is actually, as we have chosen from here 2 items already. Okay, not 2 items, I'm sorry. This is 4 items to be chosen at total. Now we have chosen 2 items. So basically I will write this down for your understanding. After choosing 2 items, we have 8 left. So basically for the third item we have 8 here, and for it to be good, because the 2 items are already good, so 2 items from here, 2 items are gone, so we have 4 items. Now the third item also has to be good, so probability is 4 by 8. Similarly, now again after we choose this, we have 7 left similarly, and after that, as from here we form this 4, we have chosen 1, so basically we will have 3 by 7. I hope this is understandable. So this will come out to be as 12 by 56, which is 3 by 14. So your answer to this question, we were asked P plus Q. This is P by Q. So basically your answer to this question is 17. This was pretty simple. Now we will proceed to the next question. So here is our next question. We have mod z is minimum of mod z minus 2 comma mod z plus 2. Now there are various ways of doing this particular question. What you can do is you can actually, if you don't want to go with that conjugate multiplication and all with the like rigorous complex numbers method, so what you can do is you can like take out mod z minus 2, mod z plus 2, find them in terms of x and y. You can find the equations. You can take mod z also, and then it will come out to be, I will try to show it also in maybe another video. I have not done that now. That will actually come out to be the shortest distance between two straight lines. This is a very standard problem. Either you can apply that, or I guess here the simplest method will be first by checking the boundary line condition. So first we will take mod z as mod z minus 2, and now I will multiply this on both sides with the conjugate, because as you know that any mod z is actually z into z conjugate. So this is z conjugate, which is equal to mod, sorry, this is not mod. Here also will actually do the same thing. This is z minus 2 into z conjugate minus 2. So now if we multiply this, this will come out to be as z conjugate minus 2z minus 2z conjugate plus 4. So basically z conjugate gets cancelled, and now if we take this to this side, this will come out to be as z conjugate equal to 2. Or from here we can say that mod z plus z conjugate is 2. Basically, okay, just a small mistake. This was nothing. I actually wrote z plus z conjugate whole mod and then this. I'm sorry. This you can ignore this part. This is what we can derive from here. This is mod z plus z conjugate equal to 2. So now we have checked with z mod of z minus 2. Similarly, what we will do is we will check with mod of z plus 2 once, because although we have to find this, but our duty is always to check both boundary line conditions. So this will become mod of z plus 2. This is again z conjugate equal to z plus 2 into z conjugate plus 2. This is 2, I guess. Don't mix between z and 2. So basically now if we multiply, this will again become z conjugate equal to z conjugate plus 2z conjugate plus 2z plus 4. This and this get cancelled. So mod of z plus z conjugate, this becomes again 2. So this was minus 2. Now if we put the mod, this will become 2. So basically, as both boundary line conditions are satisfying, so our answer is my 2 for this question. This was also simple. You can go for the geometry process, but what I will say, this is faster. Even although I wrote this step of multiplication, you don't need to do this in the exam hall, because this, if you have done this thing, will come out pretty obviously. So let's proceed to the next question now. So this is our next question. This was a very good question. So you can try it out if you want. I will solve it now. So basically we have 2 points A and B which are lying on this curve. So now first we will do is we'll try to manipulate this curve a bit. So this thing is the 2 plus e power ln of 1 minus x plus log of half 2 root under x square minus 2x plus 1. So this is basically actually simple. They have all manipulated this with log and all. This is e ln e base 1 minus x. So using properties you can bring this down and omit ln and e power. So this has become 2 plus of 1 minus x. And for this thing what you can do is you can flip this base to base 2 and bring this so that we have a minus here. And basically this is also the same case. 2 log 2 to the power log base 2 to the power 2 power of something. This power will again come down. So basically we have, okay, this is minus, I'm sorry, we have minus root under of x square minus 2x plus 1. So now one thing before proceeding, what I would like to tell is, and this will be very beneficial later on in the question, as we have 1 minus x here in the argument of log, so basically 1 minus x has to be always greater than 0. This is from range, I hope you all know. So basically x has to be less than 1. So Later on in the question, as x1, y1, sorry, not y1, x1 and x2 have to satisfy this boundary line condition, otherwise we can't take the values. Now I can write this will be 2 plus of 1 minus x, and this is 1 minus x whole squared, and because it is x less than 1, so I can open it with a positive sign. This is minus of 1 minus x. So basically this minus x and this will become as plus x, it will get cancelled, and this is 2 plus 1, 3 minus 1, so this was nothing but y equal to 2. So basically our y equals to 2 means that as x a and b points both lie on this, so basically y1 and y2 are also 2. Now we will try to find out the points, and for that we will take the curve, the circle x square plus y square equal to 13. Now the point A lies on this curve, and as we know y, we can do is we can put y directly for the point A. So from here x square is 9, so basically x equal to plus minus 3, and this is where it comes into play, this condition, because x is less than 1, we won't take plus 3. Plus 3 automatically gets rejected, and so x is minus 3. Now, so we have the point A, I guess. This comes out to be minus 3, 2, 0. Now for point B, the point B lies inside the circle. So basically you know that for any conic, if we have the equation of the conic, say the equation of the conic is s equal to 0, then if the point lies inside, say for point B, then we have to put s of b. S of b means that we put the values of point B into this expression, and that becomes less than 0. I hope you guys know this. This is the condition for inside. If it was outside, it is greater than 0, and for on any curve, it is equal to 0. So basically what I will do is this will become, okay, this particular thing is x1, I forgot to write, this is x1. So now we can write this as x2 square plus, I'm not writing y2 square, I'm directly writing 4, this is 13. So basically x2 square is less than 9, or x2 belongs to minus 3 to 3, but now we also have another condition here, which is x2 is less than 1, so I will try to bring out the common region. So basically if we draw a number line, here is minus 3, here is 1, and here is 3. So this is minus 3 to 3. I have opened the circles because this is open interval, and less than 1 is something like this. So basically this is the common region with minus 3 and 1 both excluded. So x2 belongs to minus 3 to 1. Now I will show you the question once. If you see the question carefully, we have x1, y1, x2, y2 all are integers. And now for the largest value of x2, so basically we have to take the largest value of x2, which is an integer. So basically here, as 1 is an open interval, so we can't include 1. So the maximum value, I will write this as max of x2, this will basically become 0. So now we have all the values of x1, y1, x2, y2 and everything else. y1 and y2 are equal. So basically now what we will do is we will find the results. We have an equation of line given as x minus x1 by x2 plus 3 equal to y minus, I guess, y2 by 4, and this is z minus 3 by 5. So this becomes x1 is minus 3, so x plus 3. x2 has come out to be 0, so this is x plus 3 by 3 equal to y minus y2 is 2 by 4, and z minus 3 by 5. So we will proceed to the question now. We have to read it. So basically we have to find out the shortest distance of A from the line that we have just found out, the point A. So we will try to do that. So this is our point A, say, and if this is somehow the line, as you can observe from here, this is the direction vector which will become 3, 4 and 5. I will represent it this as d vector, and this is our, I guess, the point A. Now if you drop this down, say this point is some point P. So for the general point P on this line, we will take this to be as lambda. So I'm not writing it separately. This will become 3 lambda minus 3, and this is 4 lambda, and this side plus 2, and this is 5 lambda plus 3. So basically our PA vector. This becomes 3 lambda, 4 lambda and 5 lambda plus 3. Basically we are subtracting this from this, or you could do the reverse also, no problem. So now as this is on right angle, you know the condition, right? Shortest distance. This is PA vector dot D vector. This will become 0. So this is 3 into 3 lambda, which is 9 lambda, plus 4 into 4, 16 lambda, plus 5 into 5 lambda plus 3, 25 lambda plus 15. This becomes 0. So I guess this is lambda equal to minus 15 divided by 9 plus 16 is 25 plus 25 is 50. So we can cancel this with 5. So lambda basically comes out to be minus 3 by 10. Now we have to find the distance AP. This is mod PA or mod EP, whatever you can write. So this again becomes x2 minus x1 whole squared, like that. So basically I will write out the values directly because this much you can do. This will become 9 by 10 squared, and this will come out to be, I guess, 12 by 10 squared. And now if we put minus 3 by 10 here, this is minus 15 by 10 plus 3, which is minus 15 by 10 plus 3, which is 30 minus 15. So 15 by 10 squared. And this is a whole root over. Now if we take 1 by 10 outside, this is root 81 plus 144 plus, sorry, this is 225. This is squaring the terms. So this comes out to be our root 450 by 10. Now if you observe 450 can be, I guess, factorized as 9 into 25 into 2, something like that. I will check once. 9 into 25, 15 and yeah, it's okay. So this will become 3 into 5 coming out of the root. This will become root 2, and this is divided by 10. So basically this comes out to be 5 threes are 15, and this will cancel obviously. So and to root 2 and 2 will cancel. So basically our final answer is 3 by root 2, which was a by root b, I guess. So we were to find a plus b, which is 3 plus 2. So your final answer for this question is 5. This was a good question, like general JEE advanced type, lots of complications mixed in and solving. Good question. Now I will proceed to the next question. So here is our next question. I guess this will be the best question today. This is a very good question. A very good question on by parts, integration by parts. So basically you can try this question out and try to do. I will also give you a hint if you want. The answer is hidden in this particular form. I comma b equals to a, and whatever is given, try to observe the exponents and write out something. So now I guess I will proceed with the question. So this is I a comma b given as integral x power b divided by 1 plus x squared power a dx. So as I can see that here they have one I a comma b minus 2 and x power b minus 1. So I guess I can have some idea. I will try to make this thing as b minus 1. Let's try and see what happens. So what I will do is I will make this a half, give an x power b minus 1, and we will have an x here. So x power b minus 1 plus 1 will be x power b. Now the reason I introduced this half was to make 2x here, and this is basically 1 plus x square power a dx. So as per by parts, what I will do is this is a constant anyways, I will take this part to be u and this part to be v, because as you can see v is now properly, we can integrate this. I will also integrate it separately for you guys. This is integral 2x plus 1 plus x squared power a. So if you take 1 plus x squared to be t, this becomes 2x dx dt. This is pretty simple stuff. So this is 2x dx becomes dt. This becomes t power a. So basically this is t power minus a, which is, I guess, 1 by 1 minus a t power 1 minus a, or something like this, I guess. Yeah. So I'm not substituting t, I will write this out directly. This will become an integral half x power b minus 1 kept constant. This becomes 1 by 1 minus a, I will put a bracket here, multiplied by 1 by 1 plus x squared power a minus 1. This is t power 1 minus a, I brought this to the denominator. And this will become minus of integral b minus 1 by 2 times 1 minus a. Basically what I did is x power b minus 1 is here, so I will write x power b minus 1. I will differentiate this, so b minus 1 came here, this becomes x power b minus 2. This is the 2 into 1 minus a from the previous question, and we can write out this thing 1 plus x square power a minus 1 dx. Now this is actually where the breaking point of the question lies, this term. So basically what you can see is you can notice I comma a b minus 2 here. I guess you can. Now what we will do is we will try to break this thing particularly. I will show you how. So what I will do is I will extend this step and write out so that you guys can understand. I am writing only the circled part. Please be careful. This is x power b minus 2, and what I will do is I will keep this 1 plus x square power a in the denominator, and this is divided by 1 plus x square because there is a power minus 1, so that will come to the top and this will become 1 plus x square. So what I will do is I will basically multiply this with this. So now this will become, this part is constant, so I'm writing it 1 by 1 minus a multiplied by 1 plus x square power a minus 1, and this becomes integral of b minus 1 by, okay, what I will do is I will do one thing. Because b minus 1 by 2 into 1 minus a is completely a constant, we will keep it outside this integration part. This will become integral of x power multiplying by 1, this is b minus 2 by 1 plus x squared power a dx, and this thing will be again integral x square, so b minus 2 plus 2, so x power b by 1 plus x square power a dx. And now I guess you can see this thing is actually what we need. This is I of a comma b. So yeah, and now if you notice this particular expression, this thing, this was completely equal to I a comma b itself. So now we have I a comma b on this side also. So what we will do is we will try to bring it towards the left hand side. This is basically left hand side. I've written it like this. So this will become I a comma b, and we can take a common. This is multiplied by 1 on this side, and b minus 1 by 2 into 1 minus a. If we open these braces, this will become also a minus will come here. So on that side this will become plus. So this is b minus 1 by 2 into 1 minus a, and this becomes, I will try to write it out properly. This is 1 by 2 into 1 minus a, x power of b minus 1 divided by 1 plus of x square power a minus 1, and this thing has become minus of b minus 1 by 2 into 1 minus a. And if you see this term carefully, this is our basically I of a comma b minus 2. So yeah, I can write this as I of a comma b minus 2. And now I guess the expression is almost ready. All we have to do is a little manipulation, so I will do it. So this is it. Now we can cancel out 2 into 1 minus a from everywhere because it's common in the denominator. So basically I of a comma b will become, this will come out to be, I will write this here. This will come out to be, I guess, b minus of 2a, and plus 2 minus 1 is plus 1. So it's b minus 2a plus 1. So basically I will bring it down here and divide it throughout. This will become 1 by b minus 2a plus 1 into x power b minus 1 by 1 plus x square power a minus 1, and this is plus of, I wrote plus because I will change this to 1 minus b, and this has become b minus 2a plus 1, I of a comma b minus 2. So basically this is our a capital A and this is our capital B if you compare with our final expression. So basically the hint was hidden here actually. If you find out the final expression, the hint was hidden here. All you have to do is construct that b minus 1, and after that I guess you can see automatically everything gets out. Only this particular question, I mean this particular step where we split the term, this is something that you have seen in most questions, like those sine cos questions that you have seen, complex sine cos questions in biparts that you are taught. In those questions also you see this type of a thing. So this is not something special basically, but this identifying this part was special, otherwise you can't begin the sum. So now we will put the values. So basically we have given that, okay, it's not capital A, I'm sorry, this is, just a minute. So basically we had small a given as 50, this is small a, and small b given as 97. Now an obvious question that you can ask me as, why didn't I put these values and actually find out the like normal expression in terms of numbers instead of doing all this sign manipulation? And that is because if JEE Advanced ever asks this type of a question, you should also do the same, because mingling with numbers, I guess in biparts questions, mingling with letters is or variables is much better than mingling with numbers. You can make calculation mistakes, and if anything happens here inside, the letters can, like if you make a mistake you will easily detect it using letters, but numbers will make it harder. So basically go with the letters, and in good questions they have given values here because it's an integer type question. But if it was like, say, they could have asked this in a single correct option and said what is a plus b. So basically a plus b would be 2 minus b by b minus 2a plus 1. So yeah, there could be many things, but I would recommend you try out with the letters because you are practicing now. So yeah, we will put the values. This is capital A equals to 1 by 97 minus 50 to the 100 plus 1. So basically this is minus half, and b is 1 minus 97 divided by I guess 97 minus 100 plus 1. So this comes out to be 96 by I guess 40, sorry, not 48, 96 by 2. This is 48. So basically we were asked the value of a plus b, which is 48 minus 0.5. That comes out to be 47.5. So this was a very good question on biparts. If you have done this question by your own, then it's really commendable. Give yourself a pat on the back. So yeah, this was the final question for today, I guess. I will bring out more such questions in the next videos. Thanks for watching, and do like, share and subscribe for more. Thank you.